Design strength. So there are two terminologies that are used in these steel structures, or you can say in any other structures like concrete structures. One is the capacity analysis. Second is design of structure. One is capacity analysis. Second is design of structure. Let's see and understand this philosophy: capacity of a member or a design of a structure. So this is an example to explain the difference between the member capacity and the applied load that is that of a bottle. Okay, so when I will discuss this example, so here the example start. This bottle may have a fixed liquid retaining capacity of suppose 1 liter. Means the bottle has a capacity of 1 liter. However, it may be empty at times, meaning that the amount of liquid retained in it 0 liters, but the capacity of the bottle still remains the same. You have emptied the liquid, but the capacity of the bottle, that is 1 liter. Any amount of liquid may be poured in this bottle, but that is not exceeding the 1 liter. Similarly, load capacity of a member exists with a fixed value, means any steel member has its design strength. Okay, so that is a fixed value. The applied load may have a different value, means if the capacity of a member that is 250 megapascal, but you can stress the member at 200 megapascal, 150 megapascal, 100 megapascal. The applied load may have a different value with only one condition, that the applied load must be lesser than or equal to the member capacity for stability. So that is the two different things. One is the capacity of the member. Second is we are going for design. If we are going to design for member for 200 kilonewton or 200 megapascal, then this member will survive. And if we go for design the member for 300 megapascal stress, then this member will fail because its capacity is 250 megapascal. Capacity analysis of structure. Knowing the material property and dimension of member, finding that means after knowing what is the material properties and the dimensions of the member, finding that the maximum load that can be applied on the member using the design equation is called capacity analysis, or the analysis of the structure. For example, you found the beam on the street or in the factory that is length of 3 meter, and you want to know what is the capacity. First of all, you will get the total length of the member, cross sectional dimension, what is the material property. After all getting this data, you will perform the analysis and you will get the capacity of that beam, how much that beam can take the load. So that is called capacity analysis of structure. Okay, the second one is the knowing the expected load and the span length of the member in the basic design equation, finding the required material property and cross section dimension is called design of structure. So let me explain it. For example, your client demands from you, I have a 300 kilonewton loading, so please design a member for me. So what will you will get the loading from the client, and then you will design the member in terms of cross section, in terms of length. You will design that this much length of beam and this much cross section can take your required loading. So this is called design of structure. In the design of structure, we determine the cross sectional dimension and the what will be the material, like the wood material, steel material, or concrete material can take the client load. So that is called design of structures. In steel structures, the design mainly consists of a selection out of already available sections in the market. So there is a steel sections database, like I will discuss in the coming slides, that is I section, channel section, angle section. I will discuss all these sections. So but the data for the dimensions, all the dimension data properties are given in the code or in the market. So we will pick that section and design that member. So that is the philosophy in the steel structures. Further, when we go for designing, you will get the more idea. Design of structures. Structural design. Structural design may be defined as a mixture of art and science, combining the experience, intuitive feeling for the behavior of structure with sound knowledge of principle of statics, dynamics, mechanics of material, and structure analysis to produce a safe economical structure which will serve its intended purpose. Means for going the design of structure, you should know statics, mechanics, dynamics, material properties. Okay, so all the basic knowledge will help you for the design of structures.